Welcome to Advent of Code 2024. I want to show you my solution for day 12. It seemed like a lot of people seem to have a little bit of issue. It took some people 2-3 hours to solve this puzzle. And I think particularly part 2 seemed to stump a lot of people. And I just want to really show an elegant solution, at least I think somewhat elegant solution of how you actually can make the second part fairly easy. It was fairly easy for me to get from part 1 to part 2 without a lot of issues. So I would really just like to show what my thought process was for this. So the puzzle for today, day 12, is garden groups. And really, we have a rectangular grid, and we have different plots, so different areas on this grid. So if we are seeing the plots can have different shapes like this, maybe one shape is like this, maybe one shape is like this. Maybe another plot is like this, another plot is like this, another plot is like this, right? So you have the different plots here that are called A, then this one could be called B and B, C, 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 and C, and so on. And really the idea is trying to find what is the area of each plot, and you can literally just, we try to, with similar to a breadth first or depth first search algorithm, try to really go through and try to find all the ones that are connected. Now this down here could also be called AAA. Now this is a different region, and my first mistake, that's why part 1 maybe took a little bit longer for me, is I just counted them all. I counted all the borders and I counted all the insides, and I just added them together without thinking, oh, there might be multiple A's, instead of, hey, they're all distinct. So that kind of messed up my part 1 at the beginning. But really the idea is, hey, we're taking all the areas, the whole area, so find all A's, and the way you would do is like a breadth first search algorithm. Hey, look, hey, here, okay, this one is not. Okay, then we look here and here. Well, this one is not. And then we look here and here. Well, this one is not. And then we look here and here. Well, neither of them are it. Now, the interesting thing is, well, this will also look this way, which is this isn't, and they will also look in all of these directions. And all of these are obviously not part of the same region. Now, the cool thing is, we have already found all we need in this way. With this small little algorithm, we found everything we need. We found the area, which is all the A's that we find, and we found the perimeter, which is all the connections where we don't actually find a connection. So from this A to this B, this has to have a wall because they are different. And we've already found all the individual segments that we need for part 1. Let me show you how I've coded this, or how we're gonna code this. So I've already a little example here. I'm starting my inputs, or getting my inputs, the test input. We're printing the data, and then we are getting already the test number that we will need to get. And let's code it up just to see what we need to do. Okay, and I've, just so you know, I have a little reference up here that I can get to look at. So really though, what we're looking for is a price. Okay, the price is 0, and at the end we want to print out what our price is. Okay, so price 1 is price. And in order to do that, we want to traverse through the whole data set. Okay, so to traverse through that whole data set, we want to have all the lines in a data.split, and then split it by the new lines. Okay, and then what might also be helpful is just to get the height, which is the length of the lines, and the width, which is the length of the lines, any of the lines. Because this is a rectangle, any of the lines will have the same width. What we'll also need is a scene set, just to see, this is what we're gonna use to traverse the whole array. Usually with breadth first search or depth first search, you really want to stop once you've found the optimal solution, or once you've found the first solution. In this case, we just want to traverse through the whole thing. Yet, we don't want to go through the same regions multiple times. And that's why we'll have a scene set right here that we will use to traverse through the whole thing. Now, to get to our solution, we really want to just, like I said, traverse. For y and line in enumerate lines. So now we're going through each line, we enumerate it, so we also get the which coordinate we have in y, and then we have the line, and then we say for x, and then the character in enumerate line, that gives us now the xy, and the c, the character that we have. Now, if we have already seen this specific field, if xy in seen, then we know we have already been in this square and we can continue. Which will make it that we're not looking over the same thing over and over and over again. And then we're gonna want to get the price and the scene, a new scene set from a function that we're gonna create called getArea. Just like it sometimes to split it up into different arrays, into different functions, just so that it's a little bit easier to understand. And then we say price plus equals p. Now, obviously, we don't have a getArea yet, which we're going to create right now. But really what we're having is, what we want to get out is we want to get a new the price for this area, and the area, which area are we talking? Hey, that's our entry point. XY is the entry point to look through this area. We also add the overall array of all the lines so that we can look through it. And then we also add in the scene. We don't want to go through the areas again and again and again. So even in here, we want to use this global scene set just to make sure that we're not going through them again. And then we're going to return the updated scene set. Once we have gone through every single cell in this area, we will add them all into the scene so that when we continue go through the whole array of lines, that we will not continue in this grid. How would that look like? So if we are looking back here, okay, let's take a whole bunch of these lines back out. Just a second. I've done a lot of drawings here. So as we're going through this, we will say, hey, I'm going to start here. Okay, that's my entry to the area. So I'm doing all of the ones in green, and then returning them into scene. Okay, everything that's green circle is seen now. Now if we continue here, okay, we've seen it. Okay, we have seen it. Aha, this is now our new one. Then we're going to go through every single one in this array, and then we add it back into scene. Then we're going to continue in our outer loop. Going to continue here, and then going to continue here, which is then our next area that we're going to scour through. And we find every single cell in this thing. And then afterwards, once we've found all of them, we return them back into scene, and then we're going to continue here. We don't need to go here. We continue here. We don't need to go here. We need to continue here. Okay, that's our new area. That's why I'm doing a global scene. Global scene that we're updating with each area that we find. So, and we don't need to get the area. All we want to know is the price for the area. And we add the sum of all the prices. So, define getArea. And we need the XY, we need the lines, and we need the scene. That is our function. So how are we going to do this? At the very end, what we need here to get the price, we need an area, which is 0, and we need a perimeter. And the way I'm programming right now, I'm going to make sure that it's going to be really easy for us to change it, do some minor tweaks so that we can get part 2 of it as well. So returning to get the price for day 1. So the price for day 1 will be, I can just do this, price is area times perimeter. Okay, so we're returning price, and then we're returning scene, which we have up here. We just update scene. So in here is now in the middle our magic source to get our area and our perimeter. Again, out here we have an outer loop where we just go through every single cell. We skip the cells that we have seen in our areas already. Now we want to actually systematically go through the cells where we have that actually belong to the same area. Another variable that you can create, or an array that can be helpful, is to create a D4 array. This is 4 directions. And for those 4 directions, in this case, it really doesn't matter which order they are. We really just say, hey, it goes into the 4 cardinal directions. 0, -1, -1, 0, 1, 0, and 0, 1. The order really doesn't matter as long as we look at all 4 directions. So, how do we do this now? We have area and we have perimeter that we want to get. And to go through, we start with a queue. Now, we could create a DQ and pop left for breadth first search, but since we're really just looking for every single opportunity, a depth first search will be just as fine. We go through X and Y is our starting point. That's the first item that we will look through in our loop. And we're going to loop through while the length of Q, come on, is greater than 0. As long as we have something in the queue, we want to keep searching. And we say q equals q.pop. Oh, yes, .pop. Okay, now we're looking at our very entry point, or whichever point we later on add as well. Now let's imagine we are at our very specific points. Okay, let's say we are at this point. What do we want to do? We want to look into all 4 directions and see which of them belongs to our area. If they have the same code, then they belong to the area. If they don't, they belong to a perimeter. Makes sense, right? If they belong to the perimeter, obviously we don't add this to the queue, but these 3 we do want to add to the queue. Makes sense? If we are on the outside, like this A, and we're looking up, well, we're out of bounds. This is still a perimeter that we also want to consider. So out of bounds, we also add as a perimeter. So while the length of Q, this new Q variable is our current position. Okay. So if we look at this position, that means this is part of the area, including the very first entry points. So area is plus equals 1 for every time that we find another item in the queue. Okay, and then we go for D in D4. This is our 4 cardinal directions. And we want to really say dx, dy. This is our new coordinates, are D0 plus Q0 and D1 plus Q1. What are we doing? In these 4 directions that we're going, our current position, X and Y, we're changing them up by dx and dy by just adding whatever direction we're looking at. So 0 minus 1, that means that we're going to be x and y minus 1, and so on. So we're looking at all 4 cardinal directions. Then we want to do a couple of checks. First, we want to check, hey, is dx greater or equal to the width of our lines, of our grid? And I notice now, since I'm looking at this, I'm just going to continue. If w is smaller or equal to dx, okay, I'm mixing global variables and local variables right now. Really, if you want to keep it clean, you want to add h and w here as well, or you want to just recalculate them in here. It's up to you. But w and h, they're global variables. It's attaching them. It's just it's not clean, but it's suffice for this challenge. So if dx is greater than w or equal to w, that means we're getting out of bounds in the positive direction. If dx is smaller than 0, then we're out of bounds in the negative direction. And it's not and, it's or, if any of these happen. Next one is h. If h is smaller or equal to dy, or dy is greater or equal to h, or dy is smaller than 0, then we are also out of bounds. These are 4 out of bounds cases. In any of these cases, we know we have a perimeter. Another case where we have the perimeter is if lines dy dx is unequal, is not the same as line y and x. This is our entry point. This is the one that we're looking at. So if lines y and x equals to a, well, in that case, this new one that we're looking at in the 4 cardinal directions must also be A. Otherwise, hey, it's outside of this current area that we're looking at. So if they're not the same, we know we again stepped outside of the bounds of the perimeter. Now the cool thing is, now we can just say perimeter plus equals 1. Every time we step out of bounds, this is another segment, another fence segment that we're trying to get here. Stepping here, 1, 2, right? Every time we're stepping out of bounds somewhere, that is a fence piece that we need to get our final price. So perimeter plus equal 1, and then we don't want to continue. We do want to continue in our for loop, so we don't want to calculate the rest. A second check that we need to do is if dx, dy is in scene, or if dx, dy in Q. If any of these cases if we have already seen this new square, or we have this new square already to be checked at in a second, then we don't need to add it again. And then at the very end, we can say q.append dx, dy. And that's it. Now we're having, now we're adding the 4 directions either to the Q so that we can add them to the area, or we just count the parameter if we're out of bounds. Last thing we need to do is we need to add Q to scene, because hey, we're done with this now. We have looked at this. We don't want to go back to this. Never ever again. Okay, and this is the loop to get part 1. So price for 1 is 1930. Test for part 1 is 1930. If I now change this to input, I get my final solution. That's the one that I need. I can also double check if that is the solution that I actually got. Wait here. Okay, 93. Yep, that's the same number. So this is number 1 done. Now, part 2. This is where people seem to have struggled quite a bit with, and I just really want to help out and see what we can get at. So, how do we make part 2 happen? What I did is I left this function almost exactly the same, except I've added one little thing and then added a second function to get essentially out of the parameters we can get the sides. That's as simple as it is. Okay, so out of the parameters we can get the sides. How do we do this? If we're looking back, and I'm going to make a clean slate now, and we see that we have a wall right here. Okay, and then we have the different squares along here. And then let's say this wall goes along here, and then we have a square here, here. A perimeter, again, if this was region A and this was region B, this is the perimeter because we noticed that this is the wrong place. What we want to do is what I did is I store both A and B as my perimeter. This is the constraint of my perimeter. This is how this perimeter piece is defined. And what I then want to do is I want to walk alongside this for both A and B to keep checking, hey, is this still part of the same piece? If it is, then it's still part of the same side until we get all the way down here. Now this here, you will notice this piece exists twice. Once for this and once for this. And this is where it's genius that we say, hey, A over here, but wait. This piece, yes, we have seen it, but we have only seen this A and this B, but we have not seen this A and this B. So this must be part of a different side. So by storing both A and B, we kind of store the directionality into it by accident, so that actually going through the side will make it really easy for us to construct the side of the cell. So how did I implement that? This is really easy. Instead of the perimeter itself, we want to change this up and get actually the array of the perimeter. And we want to say we want now the length of the perimeter, just to keep version 1 still working. So parameter dot append, and then what we're appending is q0, q1. That is our current cell that we're looking from, and then dx and dy. This is the cell that we're looking in. Now nothing changed for our part 1 solution. Our part 1 solution, if I go back to test, if our part 1 solution is still exactly the same, and this will be really easy. Now, one last change that we need to do is we need a second price. Okay, so we add a second price. I always like to have both solutions in my code, and we want to add here as well that out of the get area we need to have a second price. Here we add price 2, and then to get the price 2, we say area times, this time not the length of parameters, but get size, and we use parameters, the parameters. And that is this function now changed the way that we need it. And we just need to write this function get size. Okay, and for that we use the parameters. Okay, that's how we do that. Return a value. This is how we get to this. And this function is not difficult either. It's really easy to get this function as well. Again, we have now each parameter value is literally just, hey, this is where we're coming from, and this is where we're going to. And then, hey, if we have multiple that are attached to together, then they form what we know as the site. So again, we're going to create a scene variable. Now this will in fact be different to the global one that we have. Okay, so we could, to make it a little bit more clear, we could call it scene for site. Okay, just to make clear, hey, this is different than the ones that we have globally looked at. And then we want to count how many sites we have. And at the very end, we want to return those sites. That is what we want to do. That's our aim. This is what we want to work with. This is our final resolution. So we go for p in parameter. We're just iterating through each parameter, each fence segment that we have. We're just going to iterate through. Now, again, we want to do the same trick. We want to say if p is in scene, then we want to continue. We have looked at this piece already. Now, you might ask, hey, I thought we're just going through it. But here's the beautiful thing, is that is what we're doing next. We say sides plus equals 1. Hey, we just add the side because now this is a new side segment for us because we have not seen it again. And we again say for D and D4. We're going through all 4 cardinal directions. Okay, and we ourselves try to figure out, hey, can I find, if I take this current segment, can I find a matching segment in any of the 4 directions in my parameter? If that is the case, those 2 segments are attached. So if we go back here and look, if we're here and here, and then we walk down in both directions, this will be also in our parameters. So will this be. So will this be. So as long as we keep iterating and we find this next segment, then we know it's part of the same site. Now we'll keep looking here. That's still in. And as soon as we look at this one, oh wait, it's not in anymore. This one will not exist. Let me make this in green. This one will not exist in our parameter because this site does not exist. Down here. This does not exist. This does not exist. And in that way we have known that we've reached the end of this wall. And the end of this site. So we go in all 4 cardinal directions. And again, we want to say, hey, dx and dy. But we also need to have dx2 and dy2. And how do we do this? We do this p0 plus d0, p1 plus d1. Then we want to do p2 plus d0. So we're using this d for both the dx, dy, and for the dx2 and dy2. and for P3 times D1. That's now our new directions, that are new, what we hope to find the new perimeter for. If they're all along the same side, these 4 coordinates will exist in our perimeter. So we say, hey, while dx, dy, dx2, dy2 is in our perimeter, while it exists in our perimeter, we want to say, hey, scene.add, and then we add this whole thing, dy, dx2, dy2. We add this to scene, so we're not looking back at it later on, because we already then have found the side for it, and we don't want to count an extra side. And then we're gonna keep looking. We're gonna keep looking. So for each of those 4, dx plus equals d0. dy plus equals d1. dx2 plus equals d0. And dy2 plus equals d1. And that's it. This is all we need. Now I've done a little mistake here. It should be scene for side. But this will be our solution now. If we run this now, we see a mistake. What have I done wrong? What have I done wrong? Perimeters, perimeter, side, get area, sides, size plus equals 1. Price 2, P2, there we go. Price 2 equals plus equals P2. And there we go. We have the new price. And if we now do it on our bake input, we will get the answer that indeed we're looking for. There we go. That's our answer. That's how easy part 2 is to do. And we did not have to change a whole bunch of part 1. We just had to add this little calculation of how we actually calculate out of the parameters, how we calculate the sides. And that's how we do it. Bada bing, bada boom. See you next time. Bye.